guys, welcome back. So, question 13 is on the chopping block today. Pause it if you want to try, and come back for the solution. Alright, so presumably you're back now. So, we first should construct a cycle, the Born-Haber cycle, which I like to do firstly by drawing a line at the bottom, which indicates the lowest potential energy, which is Na2O, and then firstly I like to fill in the symbols first, just so that you know. Just I like to fill in the symbols first, then I plug in the numbers. You could go the other way around. Well, you can go straight to numbers, but um, ain't nobody got time for that. So what I do is, so first thing I like to do is, now note with each step of the Born-Haber cycle, you only change one small thing, whether it is the state, whether it's an ion. You go quite literally step by step. So first thing I want to do is form into standard state elements. So delta H F, which is which yields us NaS plus, which yields us 2 Na plus a half a thing of O2 gas. Then the next thing I want to do is um, vaporize Na, so 2A gas plus half O2 gas. Now note that for doing one um, for one atomization of Na, it's that delta H, but since we're atomizing two atoms of Na times delta H at Na, right? So note that that's 2 because there's 2 sodium atoms. Then I want to ionize the sodium atoms, so Na plus 2 electrons plus half a mole of O2 gas, and this would be 2 times the first ionization energy, so IE first 2 times IE1A, and note that again it's 2 because there's 2 sodium atoms, and then I want to break the OO bond, which is delta H atomization O2, and since there's only one oxygen atom, A plus 2 electrons plus O. And then lastly, we have, well, this is technically EA1 plus electron affinity 2 to form Na2Na plus O2 minus. Note that each step of this ladder is only going one rung at a time. So first we decompose it into the delta H formation, then we atomize Na, then we ionize Na, then we atomize oxygen, and then we do the electron transfer. You can really do this in any order. You can do these steps in any order you like. I just kind of picked them arbitrarily because those are the ones I remembered first. And then remember that this is all equal to the lattice enthalpy, which is the amount of energy needed to go from solid to gaseous ions, which I should note that those are gases, H lat. And then note that delta H lat, since both sides of this rung, this side of the ladder is equal to this side of the ladder, note that this is just, here, let me write delta H F on this side so that it's a little bit easier to see that since this is all a loop, you can just travel across the loop. So we know that this plus that plus that plus that plus that equals that. And then you can rearrange to get any of these other things here if you're given that. So because that's how loops work. And then if I plug in my values here that I'm given, I like to do things generally and then I put in the numbers. So and because I'm running out of space, well, not really running out of space, so let me just write this out here. Hang on. Okay, there it is. So formation enthalpy would be -4. It would be 416 plus, I like to consider absolute values and then I consider sign, plus 2 times 495 plus 2 times atomization enthalpy is 109 plus OO covalent bond enthalpy is 498 plus EA1 plus EA1 and 2 is 612 kilojoules. So there is 1, 2, 3, 4, 5. And a good way to check everything is that you make sure if you check how many steps you have, and then you check how many delta H's are given in the question, and if they match, they should be right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, which yields us a lattice enthalpy of 495 plus 2 times 109 plus 418 plus 612, which yields us a lattice enthalpy of 2,654 kilojoules. And that's our answer. Thank you very much for watching.